what you have to do here is that you have to find a value just greater than or equal to x, that is a key value given in your tree. So what it is, basically Ceil value is any value which is either equal to the given value x, okay, for example x is 3, or greater than that, okay, just greater than that will be your Ceil value. So what we did, we are iterating over a tree in which you have a root node, right? You check, there are two conditions that we are doing. So this is an iterative approach. Since I've already discussed it being on mute, that was really bad from my end. Okay, let's understand it now once again. So what I discussed was you have to find Ceil of a BST. Since this is a binary search tree, what helps us here is that you first go and check your root data. Is your root data equal to this value? No, it's not, but it is greater than that. So any value which is greater than my key value has the possibility of being the Ceil value, right? So this can be one of my possible answers, right? So if your current is right now my root value, if this data is greater than or equal to x, y equal to, I'll tell you, store your answer, means the answer will be the node, the Ceil value, right? Okay, so right now I'll store answer with this current dot data, because this can be one of the possible answers of being Ceil of x, but I don't know if this is the right answer. Once I iterate over all the nodes in the tree, I'll get the right Ceil value, okay, but since it is greater than 3, it can be one of them. So I'll store my answer with that data. And then tell me one thing, if I want to find a value which is greater than 3, right, but just greater than 3 and less than this value, why? Because I want to find the Ceil of x. The right thing would be to go in the left of 5. Why? Because if you go to the right child of 5, you are definitely going to get the value which is further greater than 5, and Ceil is a value which is either equal to the given key, x for example is 3 here, so either it is equal to 3 or it is just greater than 3, okay. So the right thing would be that you now check for the left child of 5. So you make your current point to current dot left. Right now I'm checking for this node, okay. Then I see the node data is less than my x. So can this be a Ceil? Definitely not. So if I want to find a value greater than 1, which can be the Ceil of 3, I will go to the right child of 1. This is where I fall in the else case, that is the second condition. So I make my current point to this node, okay. Now current will be your current basically is pointing to current dot right, whichever it was, now it is pointing to this. Again I check for the condition, this value is less than x. So if I want to find Ceil of 3, should I go to the left of 2 or to the right of 2? Definitely I am going to get a value greater than 2 in its right child. So again I fall into the second condition, this else condition, and current is now pointing to this node. So the moment my current is equal to the x, the key value that I want to find, if its data is equal to that, my answer will store it and I will fall into this condition. My answer will store it. Finally I return my answer. So one important thing, while this is the iterative approach, okay, till when will you keep doing this task? So once I have found my answer, I will return it. But let's say for example, instead of 3 it was 1. For example, if it was 1, you did not have any Ceil value of 3 in this. Obviously 5 was already stored, so answer is still stored with 5, right? For example, if I end up getting 1 here, which condition will I fall in? I'll go to the else case, current will point to current dot right. So this value is null, right? What will I do now? So by now, the moment I find that current is null, I should not be running any more loop, right? I should have gotten my answers by now. So I should get out of loop and return answer, which will be storing the Ceil of 3, right? So this loops breaking condition should be if you get your node equal to null value. So this is, I hope you understood all of this. I'll take one more tree and we will do a dry run so that you can understand better in case there are any doubts. Okay, let me take a tree here. So the tree I'm taking now is this one. Other test case from your question itself. So it is 10, 5, 11, 4, 7 and 8. Fine, 7 and 8. And the given x is 6. So first you tell me one thing. if you just simply you had an array or list of integers which were 10, 5, 11, 4, 7, 8, what will be the ceil? Just think it in that way. So ceil value would be, if I had found a node value equal to 6, I would have returned that node itself, but here I do not have any 6. So just a value just greater than 6 would be, there are many values which are greater than 6, 7, 8, 10 and 11, but the ceil value would be just greater than 6, so definitely my ceil should be 7. Now let's iterate over this tree and understand how are we going to solve it. So you start from the root node. Okay, so first condition would be, your question says, let me show you, wait. So see, if you see your question ceil, it says if ceil is not found, for example, all the nodes in the tree are less than the key value, right? So you will not find any ceil. In that case, you return -1. So just one more condition we'll put here. First is, if for example your root itself is a null, you return -1. Otherwise, you initialize your answer with -1, and finally what you return is your answer. So this thing can be taken care of. Let's do a dry run. So root.data is greater than the ceil value, is greater than the key value. So if you want to find a ceil, you'll go to the left of 10. Considering that this can be one possible answer, I will make my answer, right, my answer will store 10 as of now. So I'll fall in this first thing is current is not null. You go inside the loop, you check for this condition, current is 10 right now, cur.data is greater than equal to x. Okay, so first of all I store 10 in my answer, and then I move to left value, which is basically I'm moving through an iterator, which is a cur here. I've taken a node cur, which is acting as an iterator which is passing through all the nodes in the trees as per the condition. Now I have found this node, my current is pointing to 5 right now. So 5 is less than x. So if I want to find the ceil, I should go to the right child of 5 in order to find the ceil. So I'll go to the else condition, because current.data is less than, current.data is 5 is less than x. So now my current points to current.right. You can see right here. Okay, so this is where my current is going to point. Okay, then I'll check if current.data is greater than or equal to, yes, 7 is greater than x. So now my answer is not 10, it will be updated with 7 now, right, from this line of code. And then you move to the left child of 7, so that you can find a value which is just which is less than 7 and might be greater than the key value, so that I can find the ceil value. But when I go to the left side, I find it is null. So if I find it null, I'll come out of the loop, unless this makes sure that I have found the right ceil value, and which will be stored in answer. So what is the value stored in answer? 7. So that's what you return. Finally 7 will be returned. So that is pretty much about it. Let me know if you have any doubts in this. If not, I'll move to the code now. Okay, so I think that's clear. Fine, then let's move to the code, and although it's in front of you, it's pretty much about the question, but yeah, okay, let's go to the compiler and run it. So if the root is null, it's going to be, it will return -1. That is what you are handling already, your compiler is giving you. We just have to take an int answer, which I'm initializing with -1 initially. Then I'm taking an iterator by name cur. Okay, so this is pointing to root initially. Fine. Okay, now while your cur is not equal to null. Okay, what are you doing? You checking conditions if current.data is greater than or equal to your key value, right, which is key. You are first of all updating your answer with current.data, and then move your current equal to current.left. Fine. Otherwise, just move your current to current.right. And finally, once you come out of the loop, what do? You return answer. Let's check. That's all, everyone. Then we are done with this question. In the next lecture we will be discussing another problem from BST, and yeah, that's about it. Fine then, thank you everyone, let's wrap it up. See you all in the next lecture. Bye bye and take care.